What is the difference between ArrayList and LinkedList in Java? Along with this, we are going to understand all related interview question as well, as we are doing in this series with other questions as well. So first let's focus on the how ArrayList works internally, then we will relate it with LinkedList, and that will also make it clear what is the difference and what are the use cases of both of these. Before we talk about ArrayList, list comes into picture in Java. So when we have to store collection of elements, the contract for storing those collection of elements, when I say contract, that means how I can put the element, how I can get the element, how I can do the ordering among the elements, and many more things. All these contracts are defined in the list interface. There are implementation of this one, and ArrayList is one such implementation. ArrayList, LinkedList, and so on. This is the one such element. So here this video we are going to focus on the ArrayList, how it is implementing the contract of the list that is defined in this interface. When we say contract, so majorly we talk about the add method. Like when we are talking about put, that means like list has add method, right? And when we are talking about retrieval, it has a get method. So let's see how ArrayList is created in Java first. So if I have to create ArrayList, so ArrayList, we all know that is a class, and here angle brackets we have to define it is what type of elements it can hold. So let's say I'm naming it a name, so new ArrayList, and this gives us a ArrayList. First definition here is also like it is a collection of similar elements. Like if I have defined it as an string, so I cannot add integer element into this one, right? So it will contain only string element. That is what the generics comes into picture. So if I have to add something, names.add, let's say I added Codefarm, right? And names.add, next I added Arvind. So this is how I can add element, and if I have to get the element, I can pass the index. Like this is how I can retrieve the element. So now we have to understand how this add and how it is holding the elements internally. Okay, so list is an ArrayList is an resizable. When I say ArrayList, that means it is a array with special property that is resizable. So internally it is an array of elements. If I say this like this one, 0 1 2 3 4 5 this way. So whenever we are adding, let's say I added name Codefarm here, right? So Codefarm will be stored in here. Next I added Arvind here, and it will be added in here. So it will get a 0 index, it will get 1 index, 2 3 4 5 6, and so on so forth. This is how, and why we are saying this is resizable. That means initially when we are creating the array with the new ArrayList with the new keyword, it gets some initial size. Let's say it is getting a size of 16. There is a load factor comes into picture. So when we are adding the elements, and element has an internal size of the array comes to 16 into load factor, and in this case load factor is 75.75 actually. So that means when 75% of the array is filled, this array will be recreated with the new one. And what will be the new size? Initial size plus 16 into 0.75. That means 75%. I think this is the number, not 75 actually, 50% of the size of the array will be incremented by 50%, and this 50% is coming in Java 8 and plus versions. If you go to the previous versions, it was doubling the array basically. So what, let's say initial size is 16, so when resizing is happening, it will make it 32. That is why we say it is a resizable element. And the second property is like ordered. I think mentioned this one because it is an array. So if I have to retrieve it an element, I just have to go to that index and it will give me that element in order of 1. That is the beauty of this one. So when we have a use case that I want frequent retrieval from the list, ArrayList is the go-to place for that, go-to data structure for that. And whenever I have to remove the element, I can just call, so in this method itself, so whenever I have to remove element, so you can just go to names dot remove, and what object I want to remove from here. Let's say Arvind, I want to remove it here. It will look for that. Whenever you say the remove, it will go through that list, it will iterate it, it will found Arvind and it will remove that. And you see, if that Arvind is stored in here, right? So if that Arvind is stored in here, so what will happen, it will remove the element and rest of the element it has to shift in this way, right? That is why remove is costly in here. Okay, so whenever you are removing any element that is in mid of the array, so adjustment will happen, shifting will happen in the entire array, and that will make that operation costly. The same thing happens whenever you add element in between. So if you are adding the element at last, that is fine. So this operation will be order of n until unless that resizing is happening. But if you are adding element in the mid, because we have a method names.add, you can put an element at a particular index also, so that resizing will happen. So that is what it is said, that if frequent addition and frequent removal is the use case, do not use ArrayList data structure. That is going to be costly. And if we have use case for frequent retrieval, only one time insertion, this is the go-to data structure for that. Now, when I have to relate it with the linked list, so what is the similarity? So whenever I have, let's say linked list is there, so linked list is also an implementation of list. It is also implementing and it has all the methods that list has. Okay, but the way it works internally is the difference. So linked list, as the name suggests, so every element that I add into this one, it starts with a node of the linked list. So that element will be a node, and if next element I am adding into this one, so that node will be linked to this one. So there is a dynamic resizing. Obviously it is there, but not the way that it was in the array list, because internally that was array that had fixed size, right? But this linked list does not have any fixed size, because it can have a node and it can keep adding the elements whenever they are coming. And here also, if we have to remove any element from the mid, let's say this one, it just have to shift the relationship, like putting this link to the next one, and it will be removed. So, and whenever I have to add element in the between, let's say, so I just have to remove this one and put the relationship to this one and put this one, right? So whenever you have to add elements and remove elements very frequently, that for that use case, linked list is the go-to data structure for that. So both of the use cases are separate: frequent retrieval and frequent manipulation around this collection of elements. And now you see the difference. What are the difference between these? Okay, coming to the next one, like difference between ArrayList and LinkedList, I covered it already, but if you want to cover it in a point wise, so you mention it first, the underlying data structure. In the case of ArrayList, it is internally it is an array. In case of the linked list, it is a linked list, like nodes are there. Okay, and if I have to say the access time, it is an order of 1, because it is it has contiguous memory location, right? That array has a property, so it has exact location and it can retrieve that element. In case of linked list, because we have nodes connected to each other, so if I have to retrieve any element, I have to traverse the entire linked list there. So retrieval is order of n in this case. Whenever we talk about insertion and deletion, it is good up to certain limit. Whenever up to the limit when we are not resizing the array, this is the go-to data structure if we have that size known in advance. But if we don't know that size, then linked list is the go-to data structure for that. Memory overhead is the yet another thing that array list, whenever we are doing the insertion, deletion, anything, a lot of overhead happens around this one, right? Whenever it has to shift a lot of things and memory locations there, right? But that is not the case in the linked list size, because you just have to shift the address of the one node to the other node. Okay, and the next is the capacity and resizing. Array list has a definite size initially, definite capacity that it has to resize whenever that threshold is breaching. In case of linked list, there is no such threshold or anything. It can be it can have any size at any point of time. There is no resizing or no shifting in play in this one. So these are the differences that you can mention, and it will make things very clear. Yeah, I think I just explained these things. I had written this actually: insertion and deletion, memory overhead, capacity resizing, iteration performance, and in use cases, which places which one to use. Next thing, the final slide that we cover usually, what are the related interview questions. So what is the default initial capacity of an array list in Java? How does array list increase its size dynamically? We saw that. What is the time complexity of inserting an element at a specific position in an array list? That is order of n that we saw. How do you ensure thread safety while using array list? So in this case, if when it comes to thread safety, there is a method like collections is a utility class. Inside that we have a method that is synchronized list, and inside that you can pass the list, and that is how, whatever this is the return type that it is giving, it will make sure that the array list is thread safe in those cases. Explain the difference between size and capacity in the array list. I hope you have listened till now. If you have watched the video very carefully, you know the difference. Size and capacity in the array list. You see the dynamic array, internally it is an array, right? So whatever the initial size that we are given, let's say 16, so this is the capacity. Whatever the size of the internal array is, that is the capacity, and the size is the number of elements that we have inserted, like 1 2 3. Let's say 3 element I have inserted, so size will return 3, capacity will return that 16. So both are the important method, and it is important to know the differences. How do you implement a stack using ArrayList? So this is also important. Like while adding the element, you can use the usual method of ArrayList.add, but while removing the element, you can use list.remove, and you have size that -1. So that means like stack, whatever is there, whatever added last will come so stack is a list in LIFO data structure, right? Last in, first out. So whatever last element you adding, so you have to retrieve that first. So last element can be retrieved by adding this, by having this one, remove size -1, whatever is there. So that is it about related interview question, and I hope this will make a lot of things clear about ArrayList and LinkedList, and you won't miss any of the interview question if it is coming around this one. I hope you found this useful. If this is the case, don't forget to like, share and subscribe the channel, and hit the bell icon so that you get the notification when I upload any new video. I'll see you in the next one. Till then, take care. Bye bye.